And now for the part of the course I've been looking forward to. We're going to look at Docker Swarm. We're moving towards a full production system. The goal of this course is to get a full production, multiple microservice system up and running. And Docker Swarm is the way that we can distribute our application across multiple physical computers. So the point that we've got to on the course is we have a system, albeit a very simple system with just 2 containers at the moment. But each of those containers is publishing a service. We have a database service and a kind of Java container running a Spring Boot application. We've seen that we can quite easily network those containers together. And we've seen that we end up with what is basically a virtual private network using Docker networking. A very basic system. In a later chapter, I'm going to be starting up the other microservices that we built in a previous Virtual Pair Programmers course. And that will get a little bit more complicated, but bear in mind throughout that, of course, in real life, you might have several hundred of these containers to manage in your running systems. Certainly estates such as Netflix have that kind of complexity in their systems. Now, so far we've been running all of our containers on a single computer, on a single host system. And, well, of course we have, because we've been in development, so we've been developing on our local machine. But when we roll this system out to production, then we might have a scaling problem. Now, we'd be okay with this, of course. 2 containers would be absolutely fine to run on a single physical computer. But once we start scaling up to dozens or hundreds of containers, then you'd probably struggle to find a server that can cope. You would certainly need a very, very expensive server to run so many containers. So it's very common to scale horizontally, which means to distribute the containers across multiple physical computers. And Docker Swarm is a tool that enables us to do just that. In fact, Swarm is more than that. It's a full-scale so-called container orchestration system. It's going to allow us to make sure that our containers are always running, and if any container fails, then Docker Swarm will automatically restart those containers. And in fact, Docker Swarm goes quite a lot further than that, as you're going to see over the next few chapters. Now, the basic concepts in Docker Swarm is that rather than running on a single host computer, we're going to distribute across multiple so-called nodes. So, for example, we might have 4 nodes. Now, up until now, we've been on a single host system and we've been running commands such as docker container run. The big difference in a Docker Swarm is that we'll log on to one of these nodes and we're going to issue commands to Docker Swarm. I'll show you what those commands are in a moment, but they'll be very similar to the run commands that we've been doing. But the big difference is, even if we're logged into node 1 and we're issuing our commands there, then when we tell the Swarm that we want a new instance of a container, Docker Swarm will be responsible for deciding on which node that container is going to be run. And then when we go on and ask the Swarm to add further containers, again the Swarm will decide on which nodes those containers should be run. Roughly what happens is a kind of a balancing system, so that no one node has more containers than the other nodes. So that's the very basic concepts of a Docker Swarm. Now, of course, to learn Docker Swarm is going to be a bit more complicated than what we've done before, because really, to get the full benefit of using Swarm, you are going to need multiple physical computers to deal with. So in a later chapter, we are going to spin up some Amazon EC2 instances, and we'll get 4 or 5 of them, and we'll experiment with distributing our microservice architecture across it. However, I'm aware that many of you watching this course will not be interested in Amazon EC2. You might have never used it before. So for anyone in this situation, I don't want to lose you at this point. I'm going to show you a wonderful system that we can use for learning about Docker Swarm, and that's called Play with Docker. We're going to come on to that in a short while, but actually, to try out the basic commands in a Docker Swarm, you can do that on a single instance. So we're going to start by having a single node swarm. Now, of course, it's a nonsense really. You would never in production have a single node swarm. It doesn't make sense. But we can at least do that just to learn the basic commands. So let's get started. So we're back on our command line, and I don't currently have any containers running. If I do a docker container ls, nothing running, and ls-a shows I don't have any stopped containers either. I recommend if you do have containers running from previous chapters, do a docker container stop on any running containers, and then you can do a docker container prune, which will remove any stopped containers. I've probably got a stack of images, but that's absolutely fine. I can leave them there. So what we're going to do first then is we're going to start up a Docker Swarm with just a single instance, and it's going to be my development computer. Pretty much useless, but it's at least a start and we can learn the basic commands. We manage a Docker Swarm by using the docker swarm command. We're going to need some arguments into the Docker Swarm command. There aren't actually that many options for the Docker Swarm command. The one we're looking for is the command called init, and that will set up a swarm with a single node, and that's going to be the node that we're running on. So docker swarm init, and it's as simple as that. This computer is now in swarm mode. Now what it's telling me first of all is that this node is a manager. I'll talk more about what managers are a little later on. But it's telling me that if I want to add a worker to this swarm, then I need to run the following command, and it's this long command here. Docker swarm join -- token followed by some great big long unintelligible token. And what that means is all we have to do to expand this swarm is at another time, if we have another computer that has network connectivity with my original node, then all I have to do on this new node is run the command you've just seen, and then this new node will be added to the swarm. So it's quite simple to manage. Now don't worry about remembering that command because we can easily get that command back, and I'll show you how to do that later. But for now, I want to show you how to launch a container into our swarm. The big difference is, up until now, you will have been doing docker, container, run, followed by that great big long list of command line arguments. The difference is when you're working in a swarm, instead a swarm talks about services. Now I've been using the term service informally a lot on this course. So I've been talking about our web app service and our database service. For now, you can think of a service as being a container inside a swarm. There is a subtle difference, and I'll talk about that in a short while. But one of the great things about working with a swarm is that pretty much everything we have been doing previously on the course, you do it in exactly the same way in a swarm. So up until now, we've been doing a docker container run, and I've just given myself a little more space on the command line there. But what you would do now is simply feed in exactly the same command line arguments that you've been using throughout the course. We would use -d to run this service as a detached container. As usual, we'll need to connect to a network so that the containers can talk to each other. And up until now, we've been calling our network fleetman-network. Now, I think we'll find when we run this, it won't quite work, but we'll come back to that. Now, I'm going to be creating the database container here. So as usual, we're back to the tedious command line again. We need the MySQL root password environment variable set to be equal to password, and another environment variable for the MySQL underscore database, which we'll set to be called Fleetman. And finally, we need to give this service a name exactly as we did before, and I'm going to call this database. And the final parameter in here is the image that we're running from, and that's going to be MySQL. So I know it's a long, tedious command line, and we got away from command lines in the previous chapter. Don't worry, coming up very soon I'll be showing you how you can do the same things as Docker Compose within a swarm. But for now I think it's worth playing with the command line to get a feel for what's going on here. Now, as I promised, we are seeing an error here. You might at this stage be seeing an error saying the network Fleetman network does not exist, depending on what you've done in previous chapters. If you're seeing that, then don't worry, there's no problem. But this problem seems to be saying that there's something wrong with my Fleetman network that I've been using previously. And clearly it's saying it cannot be used with services. Only network scope to the swarm can be used, which is quite obscure. But the reason is, when we're working in swarm, we need a special type of network. The big difference, of course, is that our containers are now very likely to be on different physical nodes. So the communications between them are not going to be within the same host machine. They're going to be across different physical computers. And for that reason, in Swarm, we have a different type of network. It's called an overlay network. And as the caption here says, it's going to give us all of the same features that we've had on the previous network that we've been using. You might recall that that type of network is called a bridge network. The difference is this network will work across multiple nodes. It's called the overlay network. So to create one of these overlay networks is really easy. We'll do a docker network create -- driver and overlay. And by the way, there isn't a great long collection of different types of driver in Docker, or at least at the time of recording. Basically, it's either an overlay network for Swarm or a bridge network for a local single host deployment. There are a couple of other types as well, but we don't really need to use them. So we just need to give this new network a name, and we could call it Fleetman Network and simply delete the previous. In fact, I think that's what we'll do. So if we use the name Fleetman Network, we will get an error because that already exists. So we'll do a docker network rm to remove Fleetman Network. That's the old bridge version. That was successful. And now I can recall the create command. And now I have one of these new overlay networks. I get a sense that people think there's something really complicated and weird about the overlay networks, but really from this point on we will just be treating that network exactly the same as we've been treating the network up until now. So I hope now if I recall my service create command, I can't quite fit all of that onto the screen, but it's really identical to the docker container run command. All of the arguments are the same. It's just the first part of the command is different. Let's see what happens. Well, I've been given one of these weird IDs back in response. The IDs here are slightly different to the ones we've been seeing before. Previously, they were hexadecimal digits, but now we have a sequence of alphanumeric characters by the look of it. That's just a unique ID for the service. Now we can see what services we've got running with a docker service ls, and there's our new service. Now all this will have done is in the background it will have created a container for that service, and there's nothing particularly special about those containers. Even though I'm running in swarm mode, I can perfectly well drop back to the docker container ls command, and there you can see the container beginning DE is the container that this service has started. So at the moment this doesn't feel any different to what we had before, but remember, if we were running in a real multiple node system, then when we started this service, that container would have been randomly created on one of the nodes of our system, not necessarily the one that we're running on. So I hope you've got a feel for the basic commands, but I think we've really gone as far as we can with a single instance. It would be really good if we could try this in a more production-like environment. And we will be using Amazon EC2 instances later on in the course. But if you don't want to run on EC2, then there's a really attractive option that you can use for experimenting with this, and it's called Play with Docker. It's also affectionately referred to as PWD. So you'll find it at playwithdocker.com, and it will redirect to labs.playwithdocker.com. You will need to verify that you're human by clicking on Create Session. Now, what we've got here is really fantastic. This is a cloud-based system where we can spin up several instances of a physical machine. Now, actually, in real life, they're not really physical instances. They are all virtual machines, of course, but that doesn't really matter. To us, it will feel as though these are standalone computers that we can just provision at will for free. It's a really amazing service. Now, there is a restriction on it. As you can see here, there's a ticking clock, and we're given 4 hours to work with this session. In 4 hours, all of the nodes that we create will be destroyed. So obviously, we're not going to be using this in real production, but it's a great way with experimenting with Docker without incurring costs and without having all of the complexity of EC2 or Microsoft Azure or any of these cloud services. So what we can do on here, if we click on the button on the left-hand side, we can just fire up a new instance of a virtual machine. And there we are. We have an instance almost instantly provisioned. And it's a regular Linux distribution. We can do all of the usual ls, pwd to print our working directory, who am I to determine who I'm logged on as, and so on. But crucially, of course, we've got Docker installed. So I'll do a docker -- version, and yeah, Docker's installed. But we can add more instances. If I click on the Add New Instance button here on the left-hand side, that will take a few seconds, but now I've got a second instance, and I can switch between them by clicking on these links on the left-hand side. And now we can start to have some real fun. So I'm going to take both of these nodes and join them to a Docker swarm. And to do that, pick one of the instances. Let's go for node 1, and we'll do exactly the same as we did locally. We'll do a Docker swarm init. Now, often when you're running in a cloud-based environment, you get this error back saying it cannot choose an IP address because this particular system has multiple addresses on different interfaces. Now, all you have to do is pick one of these IP addresses. I'll go for the one beginning 10.0. And as suggested here, you add in the command line argument --advertise -addr followed by one of those addresses. So for me it's 10.0.16.3. It'll be different for you. So hopefully now we're seeing exactly the same kind of output that we had when we were running locally. It's telling us now that this node is running as a manager, and if we want to add a worker to this swarm, we need to run this command. Now be careful here, it is a very long command and you'll need to copy and paste this. I noticed that my command's gone off the edge of the screen there, and there's a trailing number 7 there. That's because it's using port 23774 for the Docker daemon. So we need to copy that line, and then in our other node, we haven't done anything with this node yet, paste that command in. And it's as simple as that. This node is now part of the swarm. So if we go back to node 1, we've got more commands that we can use now. We have the docker node command. And as usual with Docker commands, we can do an ls, and that will give us a list of all of the nodes in the swarm. So we're seeing 2. Any point in the future, if we want to, we can add more nodes to this swarm. And now we can simply repeat the commands that we did locally. I'll start by creating a network. Docker network create. We need the -- driver to specify the overlay driver. And the network I'm going to call fleetman - network. So that's created, and I can do a docker network ls. And there's the overlay network right there. Just out of interest, in case you're curious, if we switch across to node 2 and do a docker network ls there, you'll notice that that network doesn't appear on that list, and that's because this is a worker. You're going to find that most of the commands that we use on the manager node are not going to work here. For example, if I do the docker node ls, I get an error because this is not a manager. And that's the point of a worker. Worker nodes can't be used to issue commands, basically, although they will have containers running on them. So bear that in mind, but let's switch across back to node 1, and it's just a case now of launching services. So we'll do a docker service create, and here we go again with our long boring command. This is going to be the database service. So -d -- network fleetman -network. Oh, those environment variables again. -e mysql _root _password is going to be set equal to password. -e mysql _database will be set equal to fleetman. We need a name for this service. -- name will be database. And finally, we need the name of the image that we're running from. And remember, the MySQL image is one of the standard images on Docker Hub. And we do have network connectivity on these machines, so it will be able to download that image. Okay, that's exactly how we did it locally. Let's see what the difference is on this more realistic swarm. Well, it's responded with a service ID, and we can do a docker service ls. And what this is telling me is that currently there are no instances of this container running, but we require one instance. The reason for that is the container will be starting up in the background, and only when that container's started will that switch to a 1. If I repeat the docker service ls, yeah, that's now switched to a 1. So that means somewhere in our swarm there is a container running for the database. We don't actually know where it is. And actually when we get into production, we kind of tend not to care where it is. But if we do on this instance a docker container ls, I am seeing that database container, but you might not. It might have decided to launch that database container on the other node. So we can switch across to the other node, and although we can't run swarm commands on the worker node, you can run all of the usual docker commands. So a docker container ls will give you a list of all of the containers on this node, and it might be that your database container is running on this node. Who knows? It's a little bit random. So if we go back now to our manager node on node 1, we can run our second service, docker service create. I do apologise for the long tedium of these commands. In the next chapter, we'll be returning to this, and we'll see how we can use a tool very similar to Docker Compose to achieve what we had in the last chapter. Anyway, we need to connect this to the same network, so this will be fleetman-network again, and we need to map the port 80 to port 8080. We need to give it a name, --name, fleetman-web app, and the image. Now, if you've been pushing your Fleetman web app images to Docker Hub, feel free to use your Docker Hub ID here and the name of the image that you've pushed. If you don't have that, then feel free to use my image. So you can use virtual pair programmers /Fleetman-production. As usual, that will be downloaded from Docker Hub, although the difference is you won't see the pull happening. That will all happen in the background. So I think that's all we need for the command line. Let's see what happens this time. Again, I have a service ID returned, and a Docker service ls will confirm that we now have 2 services. Currently, the web app service is starting up, so we have 0 of 1. I'll recall that command, and I just waited long enough there, so it's now incremented up to 1 container running. But as before, if we do a Docker container ls, there's no guarantee as to which node it's going to be running on. Now, my guess is it will be on the other node because it's going to balance the containers. You're not going to see 2 containers on one node and no containers on another. So Docker container ls on this node is only showing me 1 container. But if I switch across to the other node, I can repeat the Docker container ls, and we confirm there that we have a regular Docker container running on this node. So I think that's one of the points I want to make about Docker Swarm. We have a layer of management with some very sophisticated orchestration tools, but really all that's happening underneath is regular Docker containers are being started and stopped, sort of in the background. If we go back to our manager node, we can get the logs for all of the services. Docker service logs-f, followed by the name of the service that you want to check the logs for. So here's our database. There's the MySQL log. And we can do exactly the same for the Fleetman-web app. Even though this container is running on a worker node, I can see that log from here on the manager node. I'm fairly sure that's a new feature. It used to be you had to go and find the node that the container was running on, and you had to do Docker container logs. I think it's a new feature anyway, but if it is, it's certainly a very good feature. So this is pretty wonderful. What we can see here is that we can now fire up services, and they're going to be distributed across as many nodes as we like without us having to do really very much work. We just have to think in terms of services instead of containers. And this play with Docker is really fantastic. You should find now you've got a little link up at the top, and these links are showing you all of the ports that you're exposing from this node. Now, as soon as we started that container, you might have noticed that this 80 appeared. And if you click on that link now, you now have your Fleetman containerized application published to a real running host. Now, you might notice that the little vehicles are not moving around in this system, and that's because there is a little bit of a problem with using the WebSocket technology that I've used here on Play with Docker. If you're interested, it's a problem to do with cross-site scripting, and I haven't had time to debug that problem before releasing the course. It's not serious. I'm not bothered about that. Just as long as the containers are standing up and appear to be working, I'm happy. When we move across to running this on some Amazon instances, we'd definitely want that to work, but for here, I think it's enough. So I think that's enough for a basic demo of Docker Swarm. There's still a lot more to learn with Docker Swarm, and we're going to be doing that in future chapters when we expand the architecture to incorporate our own microservices, but also we're going to spin this out onto some Amazon EC2 instances. So lots more to come with Swarm, but in the next chapter we'll look at a concept called Docker Stacks, which will certainly make working with Swarm a lot easier. I'll see you then.